Stephen swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Stephen's velocity is modeled by v of t equals 2.38 e to the negative 0.02 t sine of pi t over 56, where t is measured in seconds and v of t is measured in meters per second. A. Find all times in the interval from 0 to 90 at which Stephen changes direction. Find Stephen's acceleration at time t equals 60 seconds. Show the setup for your calculations and indicate the units of measure. Is Stephen speeding up or slowing down at t equals 60 seconds? Find the distance between Stephen's position at t equals 20 and t equals 80 seconds, and then find the total distance Stephen swims over this interval from 0 to 90 seconds. This is the AP Calculus 2023 free response question number 2. Okay, so part A. Find all times t in the interval from 0 to 90 at which Stephen changes direction. So if this is our velocity function, Stephen will change direction any time the velocity equals 0. That is, goes from positive to negative or negative to positive. So solving the equation by setting this equal to 0 is our first task. Noting that 2.38 e to the negative 0.02 t is a decaying function, this would create a damped sine wave where the amplitude will decrease over time. This sine wave has a frequency of pi over 56, and therefore it has a period of 112 seconds. If we cut that period in half, we get 56 seconds is where this function equals 0, where the velocity is 0, and goes from positive to negative. At t equals 56 seconds is where Stephen changes direction, and this is the only time Stephen changes direction. Alright, next. B says to find Stephen's acceleration at time t equals 60 seconds. Show the setup for your calculations and indicate the units of measure. Is Stephen speeding up or slowing down at this time? Well, if we give our velocity by this function, taking its derivative will give us the acceleration. So finding the derivative using both the product and chain rule, we get v prime, or the acceleration, to be equal to this function. Now plugging in t equals 60 seconds will give us the value of whether Stephen's acceleration is positive or negative, and here we see the acceleration is negative. So now we have to just check whether the velocity is negative at this point as well, and it looks like it is. So by plugging in 60 into the velocity, we get a negative value, which indicates why the acceleration is also negative. Therefore, Stephen is actually speeding up. Alright, so now part C. In part C, we are asked to find the distance between Stephen's position at time equals t equals 20 seconds and his position at time t equals 80 seconds. Show the setup for this calculation. What we're calculating here is actually the displacement between these two times. And to do this integral, we're going to have to use integration by parts. So let's consider the general integral of this form, e to the ax times sine of bx. We'll have to apply integration by parts twice. Here's the first iteration. Then taking that second integral and applying a second integration by parts, what will wind up happening is that we'll cycle back to the original integral that we started with, and we can bring that term to the other side of the equation and solve for the integral I, which we're trying to solve for. And here's what we get. Now, once we have this integral, we can plug in our constants to get the value for our specific integral. Here, a is equal to negative 0.02 and b is equal to pi over 56. That gives us the distance between Stephen's position at the two times to be 23.384 meters. Now, the last part is to find Stephen's total distance. Find the total distance Stephen swims over the time interval from 0 to 90 seconds. Now, we will have to calculate the distance with the absolute value of the velocity because we want our total distance to be measured in a positive way. Taking the absolute value of the velocity shows that the area where we get under the curve will give us the positive total distance, and that's going to be 62.164 meters that Stephen swam over this interval. And that finishes it. Hey, thanks for watching. I hope you liked this video. Please hit that like, subscribe, and notification bell for more videos. Stay tuned.